Let me this off and plug this thing in here. Okay, my name is Jim Brain. I run Retro Innovations. Some of you may have seen some of the stuff here today or some stuff online. I'm here today to talk to you about a project called EasyFlash3. Retro Innovations is going to be doing the hardware design and production of the unit. The unit is actually a follow-on from a set of products appropriately named EasyFlash1 and EasyFlash2. The first thing to talk about in this is EasyFlash started out as a way for people who have cartridge games and wanted to play those games on their Commodore machine, a way of loading those particular images onto a cartridge, many of them at one time, being able to select which cartridges, which games they wanted to play from a cartridge type situation. So that's EasyFlash1. EasyFlash1's whole goal was it was a do-it-yourselfer type of product. So it had a lot of through-hole components. You could solder it up yourself. Of course, the problem today is a lot of people are not interested in soldering up the units. And so EasyFlash, the second iteration of the product was all surface mount. But as yet, I'm not aware of it actually going into production. Along the same timeline as the second version of EasyFlash was being created, there was a bounty, if you can imagine this. There was a series of people who got together and said there is a need for a cartridge that can be plugged into the back of a Commodore machine, and that cartridge would allow you to replace the kernel, the operating system of the computer. Up to this point, the primary way of replacing the cartridge or replacing the operating system of a Commodore 64, for example, is to physically take the screws out of the back of the machine, lift it up, take the metal shield off. Hopefully the operating system ROM is socketed, in which case you pry it out of its socket and replace it with a new operating system ROM chip. Jiffy DOS is an example of that. There are others, Professional DOS, Rapid DOS, there's a number of them that have been created over the years. But as you already heard, it requires a lot of manual work in order to, you have to open up the machine, you have to take a bunch of screws out, sometimes you have to desolder the foil or the metal RF shield that's over the top of the computer. If your chip is not socketed, then that's a whole nother world of problems, because you have to find somebody in your area that could desolder the chip, install a socket. Of course, by that time you've no doubt ruined the chip that you were unsoldering from the machine. All this while, now mind you, Commodore 64 machines may only be $10, $20, but usually the people who want to do this have a sentimental machine and they really don't want to ruin it. There's a problem there. So the idea of a kernel cartridge was created, and there was a bounty placed on there, about $500, $600, for an individual to come forward and say, come up with an idea to replace a kernel, replace an operating system without opening up the machine. And so that's what I'm going to talk to you a little bit about today. What I've got on the screen here is some write-up that I'm not the designer of this product. I worked in conjunction with an individual. His name is Thomas. I'm going to go up here and get his name because I'll mess it up. I think it's Giesel, but since I've only talked to him online, I've never actually heard him pronounce it. So you'll forgive me if I said it wrong. I'm sure he will. But he took the bounty, and he had 6 months in order to create this functionality. He experimented with a couple different ideas. But finally he came up with an idea, and I'm going to explain it to you today, hopefully in a few minutes. I realize it's going to be a little bit technical, but I think everyone will at least have some interest in hearing about it. And I'm going to show you the cartridge, a little bit of it anyway, and then we'll move on in the next half hour and we'll talk about some other stuff. Thomas went together and he worked on this cartridge, and it is functional. It will be going to production shortly. The main idea being is he wanted to create this ability to replace kernels. The reason it's called EasyFlash3 is that while he was working on that functionality, he realized that all of the previous functionality that's in the EasyFlash system could be incorporated in this cartridge at essentially no charge. So essentially 2 cartridges in one, if you want to call it that. Now, I'm going to talk to you a little bit about how I guess the technical issues with replacing the cartridge. How many people understand that the Commodore 64 has 64K of RAM in it? Okay. how many people also understand that the 64K of RAM is not always visible? Right. The top 16K of the Commodore computer houses essentially, well, a little bit more than 16K, but there are two 8K areas in the top of the memory map of the Commodore 64 that do not show as RAM when you boot up the machine. For one is BASIC, which everybody knows and loves, that comes up when you boot the machine up. That's 8 kilobytes of ROM information. Then at the very top end of the computer is the kernel, the operating system. So when you boot up, all the disk accessibilities and everything, that's up at the top end. That's 8K of ROM. There's 8K of RAM sitting underneath that area, but the 8K of ROM is there. It's important because most kernel cartridge ideas simply say, well, we'll just put a cartridge, we'll just put that kernel chip at the end, on the cartridge itself. The problem with that is that in certain programs, the kernel is shifted out of memory space, so it's no longer there. So application utilities like SMORE, some games take over all the RAM and they swap the kernel out completely because they don't need it, because they don't want disk accesses, and they do their own kind of, they don't use text routines or anything like that. The problem is that whether the RAM is switched in or out is not visible at the cartridge port. So if you use a kernel cartridge, if you try to build a simplistic cartridge and say, I'm going to put a ROM on a cartridge like a game ROM, and I'm going to put it on the cartridge port, then any of the programs that try to switch out that RAM will fail. And they need that RAM. Typically those programs require that extra 8K RAM, so they will fail. So that's not useful. So I'm going to describe in a little bit, I'm going to describe here what has to be done in order to figure out what's going on. I'm going to use this as my kind of to show you some of the some diagramming and some pictures what we're talking about here. Here's the 8K kernel sitting up here. This is the 8K of space that we're most interested in. The BASIC sits down below. Kernel space is represented by a signal called high RAM. High RAM says, is there RAM available in the top 8K? And as I indicated, high RAM is not available on the cartridge port. There are two signals on the cartridge port. One's called external ROM, which is where the game ROMs typically are. And then there's another one that is ROM low, and that is available on the cartridge port. But this RAM high is not, or this high RAM is not. So the problem is you don't know. From the kernel, from the cartridge's point of view, you don't know whether kernel or RAM is being accessed when a CPU accesses any memory location from the top 8K of memory. But there's a trick. What you find out is when, in certain modes, the presence of the ROM-L, or sorry, the ROM-H in the Commodore Max machine. Anybody remember the Commodore Max machine or ever heard about the Max machine? Okay, the Max machine, obviously a different machine, but the Commodore 64 includes the Max machine or Ultimax mode. In the Ultimax mode, if you're in Ultimax mode, you can tell whether a kernel is mapped in or not by this ROM-H ability in the cartridge port. So here's what happens in this cartridge. I'm going to go right down here. This cartridge takes into effect, it takes into notice that there is ability to check out the kernel in this top area of RAM, kernel and RAM, but you only notice it when it's accessing certain other memory locations. So namely, if you're accessing locations in A0 to BFF, you can detect whether the kernel ROM is mapped in or not. You can detect from the outside pins, you know whether it is or not. So I'm going to show you what the kernel cartridge does, and then I'm going to show you actually in action. So here I'm going to get down into the signal right here. What this cartridge does is every time the CPU accesses memory, the CPU accesses memory for half of the cycle. So you have 1 megahertz operation, half that cycle is used by the CPU, half of it's used by the VIC chip. And the VIC chip doesn't always need its cycle. It needs it every once in a while, but doesn't necessarily need it all the time. And the CPU doesn't always need the cycle. So when the bus is clear, when nobody needs the CPU, what this cartridge does is it waits for a certain amount of time, and then it switches the addresses into the A0 to BFF range, very momentarily. The first thing it has to do there, it has to tri-state the CPU so the CPU is not driving the bus. So that, like the REU does, where it tells the CPU to get out of the way so the REU can do transfers, this cartridge does the same thing, but it does it for a split second. It does it for less than one cycle, less than 1/2 of one cycle. So what it does is, as soon as it sees that the bus is free, it immediately tells the CPU, get out of the way. It drives the address bus to a signal from B0 or A0 to BFF, and then immediately checks the status of those two pins, the pins that it can see on the expansion bus. If it detects one of those pins is present, then it knows that the kernel cartridge is mapped in. And then just as soon as it figures that out, it gets itself off the bus, it turns the CPU back on. Since the CPU, since less than 1/2 of one cycle has elapsed, since the CPU has been turned off, the CPU continues running because it doesn't actually know that it was turned off. Right? Got to remember that everything on the CPU is done at the cycle timelines. So as long as you clean yourself off the bus before the next cycle happens, the CPU doesn't know that anything happened to itself. So essentially you are causing the CPU to get out of the way, you're checking the status of these pins, and then you're putting the CPU back into play. Okay? So that's what these signals look like right here. So here you have the A2 to A15, which are the signals that you're going to try to figure out. You're driving those, and then in this right here, you've got, this is microseconds here. So you're waiting until this part right here, which is after the cycle has started, and you're doing your work in this amount of time. It's about 300 nanoseconds you have to do all this work. And then at the end of that time, you get out of the way, and you let the system go on. And you just keep doing that over and over and over, because just as soon as you've selected what state you're in, the user could be running a program that says, I was in kernel mode, and now I'm in RAM mode. I want to switch it. So you have to keep checking. Every time the bus is free, you check. Okay? Now, I realize it sounds a little dry and whatnot. The key is if anybody ever had a RAM link, you knew that it was that little cable that came out of the back of a RAM link, and you always had to plug it in. The reason there is because most of the cartridges prior to this, they cheated. What they would do is they would have a little wire you would plug into your cartridge, and then that wire would go inside the computer, and you'd hook onto that high RAM signal inside the computer. But the problem with that is the whole goal of this cartridge is so you don't have to open up your PC, right? You don't have to open up your Commodore. So if you have to open up your Commodore, you've ruined the whole reason for this cartridge to exist. So that everything has to be done without touching the machine at all. Here's a little bit cleaner way of looking at it. Here I noticed it's EXXX is an access, and then right here, after 120 nanoseconds, after the environment has come on, it drops this DMA line. The DMA line says CPU, get out of the way. It checks the status of the game XROM, or it checks the status of the ROM H line. It sets the game and XROM lines low because it wants to be in Ultimax mode. That's the mode it has to be in. A lot of these cute tricks that happen on the cartridge port are all because Commodore decided to try and make the Commodore 64 emulate the Ultimax. If it hadn't been for that mode, these things would not be possible. So it drops these two lines low, it watches for this line to do something. If it's low, then it knows the kernel cartridge is in place, and then it gets itself out of the road and lets the regular CPU cycle take over. Now, I can tell you about it, and it looks great, but it's much better to actually see it in action. So here we are. I'm going to switch over to the machine here. Let me get a source here. What did we decide? It was S-video? All right. And this is the cartridge. Now I'm going to show you, for right now it looks just like a regular cartridge. I'm going to pull it out, start it up so you know what's going on. So we booted it up, and we have our regular Commodore 64 Basic V2. I have nothing in my hand other than the cartridge itself. It's rather small. Shut it off. What?
Short sleeves.
And short sleeve. Dang, can't pass anything. So regular cartridge coming up, and we have, this is essentially a program that runs when you boot up the computer. This is just a regular cartridge, like a game or whatever, but this is just a utility screen. In here you have the existing EasyFlash functionality, so you have 7 slots of games that you can put in, and you can load those games in as you can tell, those who were in here, I'm having trouble with the disk drive, so I'm not going to be able to show you the program you can use to load new stuff in, but there's a utility program you can use to load whatever kinds of images that you want into 8 or 16K game images that you want in here. Here's the part that's new though. You have 8 slots in the computer or in the cartridge that you can put up to 8 different kernel images, different operating systems. So think of this as, you know, you got your Windows, you got your Linux, you got your OS 10, you got your FreeBSD, and yada yada yada, right? Anything you want. Then we're going to select one of these. So now you saw the Commodore Basic V2 show up on this machine. I hit 4, we reset, and Jiffy DOS. Right there. Jiffy DOS with all the RAM in place underneath. To an application, it will never know the difference. It will have no idea that the kernel that it is using is actually not present in the machine. It's sitting on that cartridge outside. The RAM that's being used from that top bank of memory actually also is sitting on the cartridge outside the machine. But it won't know that either. The reason for that is simply it was easier to deal with the RAM outside than it was to use the RAM inside. So any access, VIC access or CPU access to that RAM is outside on the cartridge. Now, mind you, it's pretty boring, right? But the key here is this is foundational. If you need Jiffy DOS or XOS, whatever, any kind of operating system, or you simply want to choose between multiple operating systems. For a long time, I used to have Jiffy DOS running and a product that was a parallel drive system called Rapidos. Most of you may not have heard of it. Or you may want to be writing your own operating system, right? This is a case where you can load up any of those different options. We'll bring it back up here. You can put as many options as you want, up to 8, in here. And of course, you can replace these at any time. And they are loaded through there's a utility that runs on the Commodore itself that allows you to update the images. Now, in addition, the cartridge can be updated itself. Not the RAM, but the actual functionality of the cartridge can be updated through a USB connector that's sitting on the side of it. Here, I'll shut it off and put it up here so everybody can see it. This is a prototype cartridge. The production cartridge will be a little bit longer, so it'll fit in a standard game cartridge case. But over on this side you see a mini USB connector. Probably can see it better if I show it in front. The USB connector has 2 purposes. As it's configured right now, the USB connector can update. It has a programmable logic device on the cartridge itself. And your USB connection attached to a PC can be used to update the functionality. So if there's a bug that's found or whatever, I'm a big fan of field upgradable products. And this is another one of the field upgradable products. So if there's any additional functionality, like for instance, this cartridge right here has an earlier version of the firmware, so to speak, on it. But Thomas sent me an email yesterday and said that he has updated the firmware, and I need to update this firmware, but I wasn't going to do it until the demo was over, because that's the first rule of demos, right? But I'll update it after the demo, and it now supports the action replay cartridge and some of those snapshot type cartridges. It supports those as well now. So you can load those into those banks on the right-hand side. So if you want to have action replay and retro, whatever the different options are that you want, Final Cartridge 3 and whatnot, you can have those and they'll work. He's updated the firmware. So there's a 2-step process. You'd update the firmware. I mean, you wouldn't, because I'll probably load it on that one before I ship the units. But if there's an update, you would update the firmware, and then you'd go in and you would load whatever cartridge images you want. And the cartridges, most people think of them as game cartridges, but a lot of them could be utility cartridges as well. So when you set the pins, set the jumpers to the other side, and we have tested this, you can use the USB connection as a standard transfer mechanism between your PC and your Commodore. The utility programs will allow that as well. So,
quick question.
Yes?
You're saying you load different cartridges on this. Mm-hmm. Super Snapshot?
Yes.
Even with the extra memory that's got on the board?
I will check on that.
Okay.
It does have extra memory on board, but I don't know about that. It may just be the original, the original functionality. Yes?
As far as I know, the Super Snapshot uses the maximum. Okay. Whereas some of the other cartridges don't. It's happening normally. So you do not take the snapshot.
Okay. what was I saying? Oh, the USB connection, the software for that's very minimalistic at this point. But obviously with a direct connection between your PC and the cartridge, you could do, you know, anything you can think of that transfers data back and forth, you could potentially use for that. So if the disk drive, actually it's not the disk drive is fine. If my disk was behaving a little bit better, I would show you the utility program. But essentially the program allows you to update that initial routine that shows the 2 screens. It also allows you to select and update any one of the 16 banks of software that are loaded in the machine, either the 8 banks of kernel or the 7 banks of cartridges. The 8th bank of cartridge is the actual routine that runs when you boot the machine. That's the 8th one. So when you install it, that takes the 8th slot. Questions?
Availability date?
Availability, pricing is still being worked out. I'm hoping to put together the system and have it available for $40. Availability, I've got the final board layout and everything. Hope to have it started on production by the end of the year. Probably be mid-February before the unit shows up in the store. But it will be available first quarter of 2012. Yes?
It only works for the 64, not the 128.
Ding! I was wondering when that question was come up. Thomas is working on an ability for the 128 to operate, but it's in the plans. But right now, 64 capabilities are easier to satisfy on that bus arbitration than the 128. So right now, you're talking SX64 and 64/64C.
It will work in 64 mode on 128, or
I don't know. I have not tested that. I was waiting for him to finish the code or finish the firmware, or the CPLD Verilog before I tried it out. Yes.
yeah. Since you have a CPU kind of sitting there and you're doing DMA anyways, couldn't you have just made an RU on there also?
You could have. The problem is dollars, right? The idea was to try and get the cost of the unit down. I'm hoping to get it even lower than $40, right?
Because pad work doesn't cost anything.
Huh?
I said pad work doesn't cost anything.
No.
So
It was essentially,
on there.
the problem is all that functionality grows the size of the programmable logical device that's resting.
okay.
Once you get past the size that's on this particular unit, then you go into what's called field programmable gate arrays. Cheapest field programmable gate array is $10, and it's an enormous thing, right?
Oh, so this isn't like a CPU or anything. This is just this.
No, it's not a CPU on here. It's still using all the functionality of the CPU. It's just doing those couple things. It asks the CPU to drop out, and then there's just some logic that's saying, for a little bit of time, I'm gonna drop the addresses down. I'm gonna check to see what the status of the line is, and then as soon as I figure out what it is, I'm gonna get rid of myself off the bus. That's all it's doing. So no, I guess to your original question, there's not a CPU on there.
Yeah, just because this is a tricksy electrical thing, have you guys tested it on a pretty good range of 64Cs? Because I mean, I remember, like, maybe this is a slight exaggeration, but it seemed like half of the dev time on the super CPU was when they discovered, oh, we found this whole class of 64Cs that it didn't quite work on, and this whole class of 128s it didn't work on, and so dealing with that.
There's two things for that. One is there's also the PAL versus NTSC, and there's of course different flavors. There's NTSC-M, there's NTSC, there's other NTSC, there's PAL-M, PAL-B. We've tested on a number of those units, but I can't tell you that I've tested everything. So the idea is, the way I'm marketing this is kind of a best effort type of solution, right? Because you're really working at the very edge on doing this stuff in the cartridge port. You're essentially cheating the whole system. You're saying, hey system, I really wanted access to A000. Oh, no I don't, right? That's really what you're doing. You're trying to get some data, and then you're saying, no, I didn't really care about the data that you're going to try and, the address. I just want to know whether this pin is set high or low. So in that particular area, the idea is if it doesn't work, then it's money back guarantee, right? So if you get it on a machine and it just doesn't operate, you're not going to be out anything. The key is you may not have any other option to replace kernels than breaking open your machine and putting it on there. So, and I have noticed a couple little things. The SX64, it's a little flaky at times because it's got that long ribbon cable to go to the cartridge port. So that's going to be a tough case as well. But the way I'm going to market is to say, you know what? SX users, I've been using it all day on an SX out there in the sale room. If it works, great. If it doesn't work out for you, then send it back and we'll try something else. Yeah.
So like if you were a beta tester or a developer, you can have each version of the kernel that Commodore came out with, and like JiffyDOS 5 and JiffyDOS 6 on there, and you can switch between them and test your program on each one of them.
Correct.
And have 6 machines.
That is a very good use case. Yes, indeed. Yes, indeed. So, any other questions? I don't even see a clock in here, so
About 4 or 5.
okay. So I'm doing pretty good. We started a little late, and I'm back on track.
I guess just a curiosity, I mean, well, you know, we know the JiffyDOS obvious one. Are there other really compelling kernels out there that people like us might not have heard of because they're obscure and fiddly to put in, that suddenly this exciting world would open up now that we would have an EasyFlash?
Well, obviously, my answer is going to be biased because I'm a salesperson for JiffyDOS.
But we all know about
Yes.
it.
But overseas, there's a lot of traction for products like SpeedDOS. A lot of people like SpeedDOS. In some respects, it seems like it was very, very popular. It was popular in the European area as JiffyDOS was in the States. And so there's a lot of question, do you support SpeedDOS this? Do you know, or a lot of, what I would call religious wars over SpeedDOS is better because versus JiffyDOS being better because and whatnot. At least with something like this, assuming we get to the point where we have 80 to 90% ability to satisfy the marketplace, the machines out there. My view is, okay, fine, have both, right? Have both, and I don't want to hear about it anymore, right? But SpeedDOS is one. A lot of people really liked what's called professional DOS versus rapid DOS, which are the same product, there's two different names. Chip Level Designs took the professional DOS functionality, did a little, I would say just a little bit of window dressing and released it as rapid DOS. And the key to it is it was a parallel drive transfer functionality. So the kernel was rewritten to support parallel drive routines, and you could extend the disks to 40 tracks, and it had track level buffering and a whole bunch of stuff, and it requires a lot of stuff to be loaded up into the actual 1541, but the kernel was different as well. And the problem is because the two kernels had to be sole owners of the slot or the ROM socket in the 64. You could either be RapidOS or you could be JiffyDOS, but you couldn't be both. Could not have both. So even if you had two different drives, and you had one that was a RapidOS drive and you had one that was a JiffyDOS equipped drive, if you had one computer, then you still had you had to either pop out the chips all the time to replace them, or you just had to say, well, heck, I'll use JiffyDOS because I like the functionality and the compatibility better, but I'm going to miss out on the, I can't remember, RapidOS used to load 201 blocks in like 2 seconds or something like that, so, very, very fast transfers and a lot of programmer-like functionality. So I think what this may do, in addition to that, is it may encourage people to create new kernel replacements or modify one thing people have talked about is, oh hey, wouldn't it be neat if JiffyDOS had this? We do a lot of Ethernet stuff now, or we do a lot of this now, or we'd like to have a command for changing directories because everybody seems to have either the HDs or the FDs or the micro ICs or SD2ICs or whatever. But there's no real good command. We'd like to have an easier way of doing that, or we'd like to have an easier way of changing the drive ladder or something like that. This would give people an opportunity to create one of those and load it in there and have some acid tests. Test it with a whole bunch of software. If it's just as compatible as JiffyDOS, then my license allows me to support upgraded versions of JiffyDOS. I've just never had ability to talk to somebody and say, do you have something that is as compatible and as useful as JiffyDOS? Because JiffyDOS is packed full right now, and putting something in means taking something out. And so what things do you want to take out, and is that going to affect compatibility? Any other questions? Yeah?
When you boot up the machine, it always comes up with that menu?
It does. It always comes up with that menu when you boot the machine.
What about if you have soft reset or something like that?
There is a soft reset on it, which will come back. Like if you JiffyDOS, you can come back into JiffyDOS. So as long as you leave it on and you just want to go back to what you were already in, you don't have to select it again, you can do that.
Okay, so there's a reset like that on the side?
Yes, there's two different resets.
What if you enter the software reset vector by command?
If you enter the software reset vector, then you're still, think about it, it's like the same as if the kernel is there. It's not going to, this thing's not going to matter unless you actually physically hit a button and reset it.
Okay.
Does that mean that one of them would simulate a freeze button for the cartridge? For
The one that
action
would,
replay and
you know, I'd have to
Snapshot
ask that. I
Yeah,
don't
'cause
know.
that would severely, if you don't have a freeze button, then
Yeah,
you
I
offer
think,
a snapshot.
I think the key is, and I'll have to, I don't want to take time to read my email, but I believe the one is a hard reset, the other one is essentially a reset into where you are, and the other one is like an application, like a defined mode, which would be like a freeze type of button. Because there are 3 buttons. The production unit will have the 3 buttons on the back of the unit, like one of the snapshot cartridges, and then the USB connection will be on the side, like it is today, only further back. So the cartridge is being lengthened a little bit so that it'll fit easier into machines like the SX64, which have quite a lengthy travel between the edge of the case and the actual cartridge connector buried inside.
And then you could plug the Prince of Persia killer app.
That's right, right there.
No, but tell them.
Oh, Prince of Persia. I've not actually played the game. It's a killer app, killer game, from what I hear.
Right, but it is specifically targeted
It's
for
specifically
the
for EasyFlash, and it's a port of the Apple II version of Prince of Persia. So it's specifically targeting this, and this will support any games that were set up for the EasyFlash. So that game would fit as well. So for those of you who just can't wait, then there you go. That's your first acid test, is load that game up and play it. Huh?
I'm running out.
Okay. We're going to go and do I'm going to take some time and do Zoom floppy now. So I'm going to switch gears. I'm going to switch computers here.
Okay, I'm gonna ask you to